Let's look at graphing rational functions with holes. When you have your rational function, remember that vertical asymptotes are restrictions on the denominator. With these, we're going to end up factoring, and if one of those restrictions cancels out, that is what becomes the hole. And we'll look at that in just a second. After we find any holes in the vertical asymptote, we look at horizontal asymptotes. I have this mnemonic device here, Bobo Botan Eats DC. If you haven't watched my video on asymptotes or graphing rational functions, you might want to do that. Next, we find X-intercepts, which are zeros of the numerator, Y-intercepts, which occur when X is 0, and solve for Y, and then plug in a few additional points. Let's try one. First thing that we need to do with this is factor it so we can see what's happening. To factor, we will have 3x times x minus 4 over x minus 4 x minus 1. So you can see that the x minus 4, those are going to cancel. So that is where my hole occurs. I have a hole at x equals 4. Now that I've identified the hole, I can go ahead and cross out those factors. Oh, I see I didn't put the 1 in those parentheses, and continue normally. Next would be vertical asymptote, which occurs at the restrictions in the denominator, so x equals 1. Then we would look at any horizontal asymptotes. Here we have an x to the first in the numerator, x to the first in the denominator. Exponents are the same. Divide the coefficients. Y equals 3 is the horizontal asymptote. X-intercepts. For x-intercepts, we're looking at zeros of the numerator. What value of x would make the numerator equal to 0? That would be x equals 0. Looking at y-intercepts. Y-intercepts occur when x is 0. If we replace the x's with 0, we are going to get 0. Let's put all that on our graph before we do anything else. We can't put the hole on yet. The hole will come last. But we can put our vertical asymptote at x equals 1. Our horizontal asymptote at y equals 3. Our x-intercept at 0, which is also the y-intercept, right, at 0, 0. Now to pick a few other points. Remember, we're just going to plug in. Let's try and see what happens when x is a negative 2. When x is a negative 2, the y value is a positive 2. So negative 2, positive 2, there's a point. That means I know this side looks like that. Then we want to try a point or two possibly on the right-hand side of that vertical asymptote. Let's start with looking at x equals a positive 2. When x equals positive 2, y equals positive 6. I'll go ahead and plot that point. And then let's look and see what happens maybe when x is a positive 4. We could have chosen 3 or 5 or whatever, but let's look at 4. When x equals 4, y equals 4. So I would plot that point, and I can see that my graph would do this. But remember, we are not done because we have a hole at x equals 4. So at x equals 4, we're going to follow when x equals 4, and we're just going to make that an open circle right there. So we know that there is a hole when the x value is 4. Let's look at one more. First, we need to factor. So we will have 3 times x plus 5 over x plus 5, x plus 2. I see immediately that my x plus 5s will cancel, which means again that I have a whole at x equals 5, which will just be an open circle on my graph. Now that I've identified that, I can cancel those terms out and move along. First, we would look at the vertical asymptote, which would be at x equals -2. And I'll go ahead and put that in on my graph. Then, looking at the horizontal asymptote, we are left with, we have an x to the 0 in the numerator since I canceled those terms out, and an x to the first and the bottom. So that's bigger on bottom, y equals 0. Next, X-intercepts occur at zeros of the numerator. There are none, right? There's no way to make 3 equal to 0. There's no longer a variable in the numerator. Next would be Y-intercepts. The Y-intercept occurs when you let x equal 0. If you want to look at it as y is 3 over 0 plus 2, 3/2. And that's not a line, remember, that's just the value on the y-axis. So at 1.5, I have a y-intercept. Next, we need to look at a few points. Let's start on the left-hand side of the vertical asymptote. Let's check what happens when x is a -3. When x is -3, y is -3. Let's go ahead and do one more on that side to be certain that we are correct. Let's look, Let's look at x equals -5 maybe. When x equals -5, y equals -1. I can see what's happening there on that side. Now we need to look on the right-hand side. Let's check and see what happens when x equals a -1. When x equals -1, my y value is 3. And then let's check a +1. So x equals +1. When x equals 1, y equals 1. And I can see the shape this will take. And then, remember, I have to do my whole, and my whole occurs at x equals 5. So I'm going to follow my graph, and on x equals 5, I'm just going to put an open circle. I hope you found that helpful.